So sometimes it's easy to see that the bases are the same, and sometimes it's not. So here we have this equation we're trying to solve. We've got a base of 8 here and a base of 16 there. So 8's not the same as 16, so you can't just set the exponents equal to each other. So we're going to have to use some ideas that we have about exponents, okay? So think about 8. 8 is 2 cubed, right? That's 8. And 16 is 2 to the power of 4. Now, a lot of times students look at this equation and they're thinking, oh, 8 can be 16 because I can multiply by 2. But that doesn't exactly help. So what we need to do is get those 8's, the base, to be some base to some exponent that would be the same as a base to an exponent on the other side. So anyway, I'm going to replace 8 with 2 cubed, and it'll look like this. And I'm going to replace the 16 with 2 to the 4th. So it looks like that. Now, the rule for exponents is you multiply those exponents. So you're getting 2 to the 3x plus 6 equals 2 to the 4x plus 4. You'll have to distribute, right? Okay. So 3x plus 6, 4x plus 4. Now the bases are the same. So we can pull out those exponents. 3x plus 6 has to equal 4x plus 4. So solving, we're going to get x equals 2. And then that one's done. Oh, I've got another one. All right. So we have 2 to the 5x on this one, okay. Now we have, it's a 2 in there, but we want to write that as 2 to the 1/2 power. So take it out of the radical notation and use exponential notation. Now you can see the bases are the same. So 5x is equaling 1/2. We need to solve for x. I'm going to multiply by 1/5 on both sides. You can think about dividing by 5, but it's all going to be the same. And so I get x equals 1/10. Okay. So the last one here is kind of a different one. So you look at that for a minute, and you're looking at the 3 and the -2, and you might be thinking, well, I'm not going to be able to get those bases to be the same. You're right. But there's another problem here. It doesn't matter what type of number we put in for x. If we're raising 3 to some power, it's never going to be negative. So you can think about the graph if you want to, and they might even show that in the book. But, you can put in real numbers for x all day, but you're not going to get a negative number out of it. There's no solution here. So we just write no solution. Now, we'll work with some things where the bases are not the same later on. We'll show you how to use logarithms. But this problem is kind of thrown in here just to see if you can recognize, hey, there's not going to be a solution because my base over here on the left is positive, and that's not going to get me a negative number.